So today we will learn about users, groups and permissions. So last class we have covered about the monitoring resources. So today we will learn how to manage the users. Every user is assigned a unique user ID and UID 0 identifies root. The screen is visible.
Yes, sir. Hello.
Users are assigned a home directory and program that run when they log in, usually shell. And user cannot read, write and execute each other's file without permission. Users' names and UID are stored in /etc passwd. So we will use the command cat /etc passwd. You can see this is the file where all users information is stored. So first first user is the root user, which user ID is 0 and group ID is also 0, and his home directory is /root. And if we talk about other users, you can see Duke, Vishnu, Apache, Postgres, Raj, John DK. These are the other users created in the server, and for other users, user ID and group ID started from the 1000. So please remember this. For other users, group ID and user ID will be start from 1000. Now groups. Users are assigned to group. Each groups are assigned a unique group ID, that is GID, and GIDs are stored in /etc/group. Each user is given their own private group, can be added to other groups for additional access. That means you can see here, if we talk about the John DK, this is the user ID. This is the user name. 1003, this is the user ID. 1003, this is the group ID, and the group information will be maintained in /etc/groups. You can see John DK is the group ID. Sorry, John DK is the group name, and 1003 is a group ID for the John DK user. So by default, whenever you create a user ID, his group name will be the same as the group username. So each user is given their own private group. Here you can see John DK is the private group for the user John DK. Again, can be added to other groups for additional access, that is user mode -a capital G group 1, group 2 and username. If you want to add the user with additional groups, then using the user mode command and -a for append and capital G for the additional group ID, and group name group 1, group 2 are the other groups, we can add the additional group for the user. All groups in a group can share files that belong to the group. That means here you can see, if we talk about the ff.txt, here this permission is root and user group is root. User and root and group is the root. Here if we provide a root group permission to other user, that user also access this file using the group permission of root. Okay, to create a new group, and assign groups to in one command, we can use the user add minus g username Nathan. Nathan is the user here. Using the user add command and minus g, we can create a new user and assign a group to that user. And then user add minus g users, capital G, wheel developers and Nathan. Here using in this command, we can add a additional group to the Nathan user. The groups are the wheel and developers. Okay. You can see using cat command, I have filtered the group users. Here users is a group already created, and using the command user add minus g users Nathan. That means I have created a user Nathan and assigned the users group to the Nathan. So using minus g command, we can create a user and we can also assign the groups to that user. So this is the command actually. User add minus g users. This is the group and Nathan is the user. And if we want to add additional groups to the user Nathan, we can use the command user add minus g users minus g wheel developer Nathan. That means the additional groups are wheel and developers. You can see Nath user is added to wheel and mail. These are the groups where Nath user is added. To display the users group, use the ID command, ID username. You can see using ID command, we can see the root users, user information and group information. User supplementary group, group's username. Then if you want to check the output, groups groups in NATH, NATS NATH, you can see the additional group users information using the groups command. Okay. Now groups. To create a group, we can use the command group add group name. Likewise, user add username. Using the group add command, we can create a group. Then to delete a group, group delete group name. Group add developers. You can see this group is created. If we filter out, developers group is created. So if we want to delete that group, we can use the command group delete, then group name. Then change a user's primary group. If you want to change the user's primary group, using the user mode minus G group name username. You can see Duke user is the primary group is the Duke. If you want to change the primary group, we can use the command user mode minus G group name, then username. Username will be Duke, and group name will be the another group. Well, now you can check. You can see mail group is assigned to the Duke user. To remove a user from a group, G password minus D username group name. G password minus D username will be Duke, then group will be mail. Raj, you can see here Raj is the member of Duke and Vishnu. So if we remove the Duke, yes, removing a user Raj from the group Duke. So again we will run this command. Okay. Now Vishnu is the only group assigned to the Raj user. Here previously there was Duke and Vishnu added. So add an existing user to multiple users. User mode minus a minus g group and group 2 and username. So this is the command I have already told you. So is it clear to you?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So Linux file security. Every file is owned by a user ID and a group ID. You can see these are the file present here. If we talk about the abcde.txt, this file is assigned to a user root and group is the root. And every process runs as a UID and one more group IDs. That means whenever we access this file will run with the user's group ID because this user will be access to this file. If other users are assigned to the group root, then other users can access to the file, and that process will be start with the group ID, usually determined by who runs the process. That means whenever root user will run this file or use this file, then only the process will start with the user ID, and if other users who are the member of root user started accessing this file, then the process will start with the GUIDs. Three access categories are there. Processes running with the same user ID as the file user, and processes running with the same GID as the file group, and all other processes, that is other. That means this file can be accessed by the user root and the members of the group root and the other users, because here are three types of permission are there. First three are user, second three are group, and third three are the other members. So if UID matches user's permissions apply, that means whenever root user started accessing this file and is matched to the permission of the file, then user's permission apply, otherwise GID permission may, apply, or group's permission apply, else neither user and group matches, other permission apply. That means if root user start accessing the abcde file, then root user's permission, that is read, write and execute, will apply, else group permission, that is only read, is apply, else other users read is also apply. That means three type of permission can be used here. One is user, group and others. Then permission types. Permission type are three type. R stands to read, W stands to write, and X stands to execute. Here you can see read stands to R stands to read, W for write, and X for the execute. And hyphen no permission in place of R, W, and X. Whenever R, W is not present and only hyper is present, then no permission are applied there. To examine the permission or view the permission, we can use the command ls minus l. You can say ls minus l. See, using the ls minus l, we can see the permission of the ab.txt file. Now, file type of permissions represented by the 10 character string. From here, you can count 10 character string is assigned to the permission of a file. These are the 10 characters. And out of this, first three are user, then group, then for others. Okay. Here you can see, I have already told you R for read, W for write, and X stands for execute. So here you can see user having the full permission read, write and execute, and groups having the permission read and execute only, write is not present. For other users also read and execute present, write is not present. So interpreting permission. So read, write and execute for the owner and root, read and execute for the members of trusted group and root, no access for other users. If you talk about this uh, file permission as an example, here no access for the all users are here. You can see changing a file ownership. To change a ownership, here you can see these are the owner of the files. If you want to change the ownership of a file, we can use the command user own. chown is the command, and if you use a -r option, it will change the permission for the subdirectories also. So if I will change the permission of the abc.txt, chown Vishnu colon Vishnu abc.txt, you can see for abc text user Vishnu and group Vishnu is changed. If I want to only change the user, not the group, root for the ff test, you can see for ff test user is Vishnu and group is the root. So likewise, using the combination, we can change the ownership of a file and a directory using the chown command. In case of directory, if we want to change the permission of the subdirectory also, we have to use the command chown minus capital R. Okay. Then changing permissions, symbolic method. So using symbolic method means U, G or O. That means U stand for user, G stand for group and O stand for the other. Then plus or minus for grant or deny. Plus uses for grant and minus use for deny. And read, write, execute, read, write and execute permission. For example, if we use the UGO plus R, here it will grant a read access to the all. That means user, group and others. Okay, if you use O minus WX, it will deny read and execute for the other users. So changing permission using numeric method. Numeric method means this will be 4, this will be 2, and this will be 1. And if we count, it will be exactly 7. That means 4, 2, 1. It is 7. That means read, write, and execute. If we assign 7, then it will assign the full permission, that is read, write, and execute. Here, if we will take this example, here it is the 7. Then read and execute. Read means 4, execute is 1, that is 5, and here also it is 5. So if we talk about the complete permission, it will be 755. Okay. So accordingly, we can change the permission. Here it is a file gg.txt. If we want to give the full permission to this file, we can use the command chmod 777 gg.txt. Now you can check gg having the full permission. If we want to only give the read and execute, not the write permission, what we will do? We will deduct the 2. That means it will be 5 only. 4 plus 1 5, and command will be chmod 555 gg.txt. Now you can check there only read and execute permission is assigned to the user. So accordingly, using the combination of the 4, 2, and 1, we can give the permission to a file or a directory. Is it clear to you?
Yes, sir.
Okay. So now sticky bit. Sticky bit is a special permission using which files in a directory with sticky bit set can only be removed by the owner or the root, and regardless of the write permission to a directory. That means whenever sticky bit permission is applied to a directory, no user can delete other users' file. So here, if we take an example, now I am in root directory. Create a folder here, create a directory here, mk using the command my mkdir. Sticky bit. I have created a user sticky bit. Now create files. I have created a root.txt using the user root. Now I am in Duke user cd/sticky bit. Now create a file here, duke.txt. Okay, we need to give the full permission because you can see ls -l /sticky bit. Only read and write permission is available for the root user only. So we need to give the full permission using the chmod command 777/sticky. Vishnu. Now go to the sticky bit user directory. You can see we have created a duke.txt using the duke user. Now using the Vishnu user, we will create a file vishnu.txt. Now you can see using three user we have created three files. Now using the Vishnu user, let's try to delete the duke users file. Now I am in Vishnu user. Let us try to delete the duke users file. rm-rf duke.txt. Now you can see using the Vishnu user, I am able to delete the duke users file. So let us try to delete Vishnu users file by the duke user rm-rf Vishnu.txt. You can see one user can able to delete the other user's file, and this should not be happen in the real-time server. So what we will do, we will give the sticky bit permission to deny this activity, and our command will be chmod +t directory name. Now again create the files. You can see three files are again I have created. Now give the sticky bit permission chmod +t/sticky bit. Now take the permission. In case of sticky bit, you can see one T is added here. Is it visible to you? So this is the sticky
Yes, sir.
bit permission. Yes, this is the sticky bit permission. Now check if DQ user is able to delete the root user Vishnu user's file. rm-rf, you can see operation not permitted. And now try with Vishnu user to delete the Duke user's file. Operation not permitted. So using the sticky bit permission, we can deny the delete operation by one user for the other user's file. So this is the work of the sticky bit. Is it clear? Sukan Chinmay, is it clear?
Yes, sir.
Okay. To remove the sticky bit, we have to use the command chmod -t, then directory name. Now check if we will remove the sticky bit -t. You can see here T is not available now, and now try to remove the Vishnu users file. You can see Duke user now able to delete the Vishnu users file, and in case of Vishnu also, you can see Vishnu user able to delete the Duke users file. So this is the work of the sticky bit.